All right, so we're going to talk about Chapter 1, Introduction to Statistics. And before we start, I want to talk a little bit about some notes about the class. So before we get too deep into the semester, I want to reiterate that this project that you're doing for class is not your actual dissertation, but a dry run for your dissertation. Your topic can be the same as your actual dissertation, but it's not going to be the actual dissertation, meaning what you do for me this semester is not going to be nearly enough to call a full dissertation project. This is a practice run. If you're not sure what you're going to be doing for your dissertation, you'll need to figure out what you'll do for the class project. And yes, it's best for you if they match, but I'm going to have to grade what is in front of me. And if your design and research questions for your dissertation don't match what you've done for this semester, then I can't give you full points. So I want you to focus on the class project, and if it's something that you could fold into a dissertation later on, that's fantastic. But I want to focus on one quantitative research question for this class, and I don't want more than one. If you have more than one for your actual dissertation, that's fantastic. Put them away until you're ready to do the real thing. I just want one. Some notes about this class: you're going to submit one paper to me and the same paper to Dr. Orange. So you don't have to write two separate papers. You're going to write one for both of us. She's going to grade your qualitative part, and I'm going to grade your quantitative part. Now, just to reiterate, on the left-hand side is what I do, quantitative research designs, and on the right is what she does, qualitative research designs. I do experiments, quasi-experiments, correlational studies, and yes, surveys are quantitative, not qualitative. And then other non-experimental research studies. And we answer predetermined questions in order to generalize our findings back to a population. In qualitative, it's different. They do case studies, ethnographies, grounded theory, narrative, content analysis. Their purpose is to explore, and they don't generalize findings back to anyone. So I just want to reiterate that because it's very important that you understand the difference between the two. Okay, so if you do not have the correct results that match your research question and proposed analysis, you will not be able to pass the final project. The point is that you're going to have actual real data, and in order to have real data, you need to send out a survey. So even if you're going to be doing something different for your dissertation, for this class, you're going to find a survey and we'll use it. So the goal is to have a complete paper as an example and a guide for your real dissertation at the end of this class. If you have the wherewithal and it can be close to the real thing, it doesn't have to be, but your paper must be a rigorous research study, even if it's only one research question. So why do we use statistics? We use them in order to present data that you have gathered as a researcher in a coherent way so that others can easily digest your information. And it also helps you make decisions whether or not the findings that you found were due to chance alone or were they significant. And if they're significant findings, whether or not you can generalize those findings back to the broader population. So I keep saying population. So the population is the set of all individuals of interest. So if I'm looking at special ed students in 6th through 8th grade, then my population of interest is all special ed students between the grades of 6 and 8. But my sample might be 50 kids from 2 different middle schools. So those are the individuals selected from the population, usually intended to represent the population, and then whatever we find with our samples, we then generalize back to the broader population. So the way this works is you have the population, which is all the individuals of interest. From them, we select a sample, and then from the sample, these are the people that were participating in this research study. Either we sent as many people as we could get a survey, and the people who self-select into the survey are the ones who are our sample. We generate our findings, we get the results, and then we try to generalize back to the population. All right, so we have a variable, which is a characteristic or condition that can change or have different values. So if it's a variable that can change, perhaps somebody's score, or if it's a variable that is different for different people in the population, like gender, race, ethnicity, etc. Data is plural, so we say data are. Data are measurements or observations. So the data set is the complete set of measurements, and then datum is the singular for one measurement. And it's commonly called a score or a raw score. Nobody ever says datum. Okay, so a parameter is a value that's describing the population, some measurement of the population, and a statistic is some measurement of a sample. And I'm going to give you a little mnemonic to help you remember that. So you will see Greek in statistics. So parameter is a numerical characteristic of a population. And parameter starts with P, and population conveniently starts with P. And then we also know that this little pi, we're familiar with that, is also the letter P in Greek. So parameter is to population, and then the Greek letter represents parameters. So in Greek, the m, mu, is the mean. This is a lowercase sigma. Sigma squared is the variance. And sigma, the square root of the variance, sigma is the standard deviation. You don't have to know that. I just want you to see that when you see these Greek letters, they refer to the parameter of the population. Now, when you see an S in the Latin script, S is a statistic, which is a descriptive measure of a sample, which also conveniently starts with S. So statistic is to sample, as parameter is to population. This is a measure of a sample, and they use the letters we use every day. Sometimes you will see this thing with an X with a line over it, which is pronounced X bar. We're just going to use a capital M to mean mean. And then where S is the sigma squared is the variance of the population, S squared is the variance of the sample, whereas S is the standard deviation of the sample. So I'll say one more time. Parameter is to population, as statistic is to sample. All right, and we have different types of variables. So, and this is very, very, very important in terms of your research questions and the way that you write research questions, which we'll talk later on in the semester. But when you write a research question, I should be able to just pinpoint with, like pointing with my finger and your sentence, or your research question, this is a variable and this is a variable. So there are different kinds. A discrete variable consists of separate, indivisible categories. So no values can exist between two neighboring categories. So like live births, deaths, students in class. Whole numbers only. You can't have half of a live birth. You can't have half of a death. It's either there or it's not there, right? You can't have half of a student. So those are discrete variables, and continuous variables contain an infinite number of possible values that fall between any two observed values, and it's divisible into an infinite number of fractional parts like height, weight, scores on tests, etc. And then continuous variables, when you're measuring a continuous variable, it's going to be very rare to obtain identical measurements from two different individuals. It's actually an interval that must be defined by boundaries. So it's just this upper real limit is at the top ceiling and lower real limit is at the bottom, which is the floor. Sometimes you'll hear about ceiling effects and floor effects. So if you have a score, right, the floor would be 0 and 100 would be the ceiling. And those are the boundaries of intervals for scores that represent a continuous number line, or that are represented on a continuous number line. So we have different kinds of variables, and I talked about this last semester. In order to establish relationships between variables, researchers must observe the variables and record them. So this means that in order to be able to do these types of statistics with them, they have to be quantified or measured, right? So the process of measuring it requires a set of categories called the scales of measurement, or a scale of measurement. And the process classifies each individual into one category. So, perhaps you've heard of film noir, right? This is from The Big Combo, this picture in 1955. These are dark black and white movies that are usually thrillers or mysteries, crime dramas. So you've heard of film noir. Noir is a French word that means black, and also it is an acronym to remember the scales of measurement. So N is nominal, ordinal, interval, and ratio, and I'm going to explain what each one of these are. So nominal also has another name that you're going to hear me say a lot, categorical. Nominal and categorical mean the same thing. They're just naming variables. You'll see the word N-O-M, nom. Nom is the Latin root for name. If you know Spanish, nombre means somebody's name. So nom is a naming variable. So gender, where 1 is equal to female and 2 is equal to male, it's just a label. It's not quantity of something. Ordinal is like birth order or a Yelp review, right? Stars, 1 star, 2 star, 3 star. The difference between a 1 star and a 2 star, you know that their 2 is more of something, but we don't know how much more, because my 1 star may be different than your 2 star or your 1 star. So it's ordinal, but it's not as clear, and the distance between each point in the order is not necessarily the same. Then we have interval, and if you can't tell, that's a thermometer. And the reason why interval is different than ratio is that in interval, a 0 is just a placeholder. So if I say it's 0 degrees outside, it doesn't mean there's no temperature outside. It just is a placeholder. It means it's cold on the Fahrenheit scale. And it doesn't mean absence of. Whereas ratio is the bathroom scale. If I get off that bathroom scale, it goes back to 0, meaning there's no weight on the scale. When I get on it, it registers the weight. So we have nominal, ordinal, interval, and ratio. And in SPSS, it's going to combine these last two and just call it scale. So it's going to say nominal, ordinal, and scale, but it goes from bottom to top, and I'll show you that when we get into SPSS. All right, so we have different types of statistics, descriptive and inferential. So descriptive statistics are just summary statistics. What's the frequency of these males and females in my data set? What's the average age? They're not. You can tell me. I could take an average of your scores in your class of your kids, and I can compare them to the average of scores in my class with my kids, and we can look at them descriptively and say, oh look, mine made 95 and yours made 100 on average. Yours is descriptively higher, but we don't know if they're statistically significantly higher. When we do that, we're into inferential statistics, and these are techniques that you're going to learn about this semester that tell you whether or not what you found is by chance or not by chance. And if it's not by chance, we say it's significant, and if there's a significant difference, we can say that the resulting difference is due to some sort of effect. And then sampling error is just the normal occurring discrepancy or error that exists between the sample statistic and the population parameter. For example, you have 1,000 college kids. All right, we're gonna take the average age, 21.3 years. Of those 1,000 kids, the average IQ is 112, 65% female, 35% male. I pull sample 1, I get 5 kids. Average age is slightly lower than the population parameter. The IQ is also slightly lower than the population IQ. And we still have similar but not the same proportions of females to males. Then I pull another sample at random. I get a little closer to the average age. I'm closer, a little actually higher than the average IQ, and I'm still not quite at the actual proportions of male to female. And these differences between these two samples, tiny samples, are just called sampling error. Okay, so individual variables and relationships among variables. So we have kind of 3 different types of studies that we can do, and you can have combinations of these. So you can ask research questions, or you can do an entire research study. Nobody will do an entire dissertation solely of descriptive statistics. You'll have to have some inferential statistics. But some research questions are just descriptive in nature, and those are just using descriptive statistics. What's the mean? What's the average? What's the proportion? And then those are research questions that just want to describe individual variables as they exist. Then some research is intended to examine relationships between two or more variables. That's a certain type of study, and we talked about that last semester. That's a correlational study. And then some studies are conducted to determine differences between two or more groups on some outcome or dependent variable. So we have descriptive, and then the second two bullets are both inferential, but they're different. One's looking at relationships and one's looking at differences. Now, you're not beholden to do just one or the other. You could have 5 different research questions, not for this class project, but in your dissertation, and in one of your questions you could look at relationships, and then another question you could look at differences. There's no rules in how many and how you have to do it. So these studies, descriptive, I just kind of said this already, descriptive studies that don't use inferential statistics. Here's an example of a research question. How many students receiving services for special education also receive occupational therapy services? This is just percentages and or frequencies. Correlational method is when 2 different variables determine whether there's a relationship between them. So when the data is numerical, remember when they're continuous, numerical like score 1 and score 2, we're looking and we want to look at the relationship, we're talking about a correlation. If we're looking at 2 variables that are categorical, we're going to still examine relationships, but we're not using correlation, we're using what's called a chi-square test, which we'll get into later in the semester. All right, so if I'm looking at the relationship, the wake-up time and the academic performance, I can plot these on a scatter plot, and I can see that the later you wake up, the poorer you do on your GPA. So if I wake up at 12, I make a 2.2. If I wake up at 7, I make a 3.8. This here is more of a chi-square type test. So males and females, and whether or not they prefer to text or talk on the cell phone. These are frequency counts. I would do a different statistical analysis called a chi-square to determine whether there's a significant relationship between gender and cell phone preference. And we'll get into that later on. And then the correlational studies cannot determine cause and effect. Just because there's a relationship there does not mean that one cause the other. You've heard this before, correlation does not imply causation. All right, so we have 2 types of research designs, experimental and non-experimental methods. And in only a true experiment can you actually determine cause and effect. In an experiment, you examine the difference between or among groups on some continuous outcome measure, and I have the asterisk because not all dependent variables have to be continuous. And then a non-experimental study does not permit a cause and effect explanation. Here's an example from the book. It's a graph that they show, and I want to just kind of give you a heads up about how things would look in SPSS. Here we have two groups of children. These guys watched a violent video game or played a violent video game, and these guys played a non-violent video game. And then these are scores on some aggressive behavior measurement. They have them in two separate columns, but the way I would input this into SPSS is I would code the variable type of video game as 1 equal violent, 2 is equal to non-violent, and then my other variable would be the behavior score. And you can see that the first 3 from here are 7, 8, 10, and the first 3 from the non-violent are 8, 4, 8. I just put the dots because I didn't want to do all 20. But this is how you would input it into SPSS. So the goal of the experiment is to determine cause and effect, right? You're going to manipulate one variable by changing its value from one level to another. Either you get the treatment or you don't. And you must exercise control over the research situation to ensure that extraneous or confounding variables do not influence the relationship being examined. We have different types of variables. You have the participant variables, which you can't necessarily control, right? You get who you get in terms of age, gender, and intelligence, for example, and they vary from individuals, from one person to the next. Environmental variables, such as lighting, time of day, and weather, we can control. So we use 3 methods in order to control over our experiments. We can use random assignment, which is the best way to equate groups. If I pull out of a hat 100 names, and I randomly assign. I pull the first name, they go in the treatment, pull the second name, they go in the control, and just do that until all the names are done. That is the best way to equate groups. If I can't do that, I can match a second grade male to a second grade male, one in the treatment, one in the control, and match them on race, ethnicity, language, special ed status. As much as I can compare those two and can make them as equivalent as possible, I can do that. I can also hold constant, right? So if I want to do an outside intervention, I could say I'm only going to do it on sunny days for both the treatment and the control, and that way we eliminate there was a weather threat to validity. Okay, so we have the independent variable and the dependent variable. We said this last semester. The independent variable is something that I manipulate, and the dependent variable depends on the thing that was manipulated. So whether or not you were in the treatment or the control could be the independent variable, and then the outcome measure could be a score on a test. And we'll talk more about these as we go through the semester. So individuals in the control condition is business as usual, or it's a placebo, but we don't do that in education studies, so it's usually just business as usual, and then the treatment group or the experimental condition gets some sort of intervention. In a non-equivalent group study, this is also called a quasi-experiment. This is typically what we do because we get kids that are already given to us in classrooms or in groups or in schools. And so we compare them. We can say this school got this positive behavior interventions and supports, for example, and this other school didn't. And so we're going to compare them. We've matched them as best we can on free or reduced lunch status and all these different characteristics of the school size, demographics, etc. But we can't randomly assign kids, you go to school A, you go to school B. Right? So these are non-equivalent groups. So in a pre and post study, you have two groups of scores that are obtained by measuring the same variable twice for each participant. You get a pre-test, you get a post-test. We can't control the passage of time. The before scores have to be measured before the after scores. And just because there's a difference, that may be caused by the treatment, it's always possible that the scores simply just change as the time has passed. So in a non-experimental study, the independent variable is used to create the different groups of scores. It's also called the quasi-independent variable. I've only heard that in this textbook, so take that with a grain of salt. But this is a non-equivalent group study is called a quasi-experiment. And so these guys are calling this quasi-independent variable. Just take that with a grain of salt. I've only heard it in this text. All right, so here's some non-experimental studies, and I just wanted to show you. So here's one. Subject is gender. The quasi-independent variable is gender. It's not manipulated, but it's used to create two groups of studies. The dependent variable is test scores measured in each of the two groups. And again, you would do it the same way. Gender would be 1s and 2s, and then the scores would be listed in the second column in SPSS. Now this is a little bit different. This is a pre and a post test. So I would have time as my independent variable, so pre and then post, and this is the same individual. So this kid had a score of something at 17, and then after he or she got therapy, it was 12. And in SPSS, you would list these out the same way. And we would do a paired samples t-test, which we will get to. So this is depression scores. Okay. So really quickly, we talked about this last semester, but I just want to go over it again. Constructs are internal attributes or characteristics that cannot be directly observed, but are useful for describing and explaining a behavior. For example, leadership or self-efficacy or sense of belonging. I can't just look at you and say, you have good leadership skills. I would have to measure it. So I have to operationally define, which identifies a measurement procedure for measuring an external behavior, and then uses the results of the measurements as a definition and measurement of a hypothetical construct. So for example, in order to say that you have good leadership skills or look at the relationship between leadership and sense of belonging, I have to give you some sort of instrument, perhaps a survey, in order to assess whether your leadership skills correlate with your sense of belonging or self-efficacy. And in order to do that, you'd have to take this survey, and I would have to score the survey. And if you have, say for example, higher numbers mean stronger sense of leadership. If you have high scores on leadership and also high scores on self-efficacy, and it's scored similarly, then I would say that there is a positive relationship. Stronger leadership skills mean stronger senses of self-efficacy or sense of belonging, etc. Okay, so we're going to do a little bit of arithmetic because this is statistics, and we are going to have a little bit of math at the beginning of the semester, and then we'll switch to SPSS. But if you remember the order of operations, we have parentheses, exponents, multiplication, division, addition, and subtraction. So first what we do is in parentheses. Then we do, after we've done that, we raise to the power. Then we multiply, divide, add, and subtract, going from left to right. So let's, oops, I'm on the wrong slide. So same thing. Here, let's do this practice. So if we're going left to right, we see, okay, we have a parenthesis. So we do what is in the parentheses first. So we say 6 minus 4 is 2. Then we're going to square it, which is 4. So I'm going to rewrite the problem. 100 minus 3 times 12 divided by 4. Okay, so we multiply first. So we're going to say 3 times 12 is 36. Then we divide 36 by 4 is 9. Then we subtract. 100 minus 9 is 91. Now let's try this one. Pause it here and see if you can get it right. And so here's the correct answer is -4. Alright, so we're going to do a little bit of easy algebra. So this is just simplifying. When you see an x, you're going to plug in a 5, right? There's no equal signs. We're just simplifying, getting to the smallest number. So we're going to see x plus 2, so I plug in 5 plus 2 and I get 7. 2x plus 5 minus 3, I plug in 5. 2 times 5 plus 5 minus 3. Going left to right, 10 plus 5 minus 3. So 10 plus 5 is 15, minus 3 is 12. And again, 4x plus 2x minus 6. I plug in 5s everywhere. I'm going to do what's inside the parentheses first. So first I'm going to multiply. I'm going to say 10 minus 6, and 4 times 5 is 20. So 20 plus 10 minus 6. So 20 plus 4 is 24. Okay, and then we're going to solve for x. Now we have an equal sign. And the same thing, if I'm just going to try to isolate the x and then figure out what the x value is. So I have 3x plus 4 is equal to 10. I say 3x is equal to 10. I got to bring this 4 over, so I do that by subtracting. So I say 3x is equal to 6. I divide both sides by 3 to get rid of this 3. These guys cancel, so I get 6 divided by 3. X is equal to 2. If I want to check myself, I plug 2 back in here. 3 times 2 is 6, plus 4 is 10. Yes, I got that right. 18 is equal to 9x. I divide both sides by 9, and I get x is equal to 2. And then this one's a little bit tricky. I have 2 over x times 8. If I multiply both sides by x, these cancel. So then it leaves me with 8x is equal to 2. I divide both sides by 8, and I get x is equal to 1/4, or x is equal to 0.25. Alright, briefly. N is the number of scores in a population. I'm just talking about notation. You sometimes will say, I think it says in the book, that lowercase n is the number of scores in a subset of your sample, where n is equal to 50 participants. The lowercase n would be 25 males, and lowercase n is 25 females, but you often don't see this. You don't see this often in published research anymore. This capital sigma is not it's not a parameter, it's not a measure of a population. It is actually an operator. It's telling us summation. So we're heading to the sum of squares. So x is a score, it's a variable, it could be any number. Same with y. So if I say x is 4 and y is 7, then x minus y for each row in these in this data set, I would take x and subtract y. So that's 4 minus 7 is -3. And then if I say take that value and square it, I say -3 squared is 9. 5 minus 4 is 1. 1 squared is 1. 9 minus 7 is 2. 2 squared is 4. 1 minus 8 is -7. -7 squared is 49. And 3 minus 5 is -2. -2 squared is 4. Now if I say sum this column, I'm not squaring it, I'm just saying sum this value, x minus y squared. So that's 9 plus 1 plus 4 plus 49 plus 4 is 67. And here, again, I say it's just a Greek S or a sigma. It's not a parameter, it's just summation. Now, last thing. The Southwest Educational Research Association is a regional affiliate of the American Educational Research Association, which is our top-tier professional organization and conference held yearly. This year, I believe it will be virtual, or next year rather. It's usually in April of, they do call for proposals in the summer, and then you usually find out if you got in or not in early November, and then you present at the conference in April. This year it would have been in San Francisco. Sadly, we didn't get to go. Next year it was supposed to be in Orlando, but it's going to be virtual. I think the following year will be Chicago. But SCRA is our regional affiliate. It goes back and forth between San Antonio and New Orleans. Again, this will be virtual. February 3rd through 5th. It's really, really fun. We always have a good showing, and you guys are going to submit. You don't have to, but I strongly encourage you to submit to the Graduate Student SIG, which we'll talk about in class this week. All right.